Hey everyone, in this video we're going to be starting power series or section 11.8. So this section is about three main things. It's just what a power series is, how to find where it converges, and how to find the radius and interval of convergence. So what is a power series? Well, a power series is a series that looks like, as you can see, it's just a series with a center or a constant times a term, I guess you could say. Or generally it's going to be written as a constant times x minus a to the nth power, where the number a is called the center of the power series. And if the series just uses x to the n, so like the first one, right here I'll highlight it, then the center is going to be 0 for that series. However, if it uses the x minus a to the n, then the center is at a. So for example, or actually before that, so basically a power series is just built from the powers of how far x is from the center. So it might sound confusing, but we'll clear it up. So now for the examples, as you can see, the first one, c to the n times x to the n, is centered at 0, right? And then the second one, the x minus 2 to the n, is centered at 2. And lastly, x plus 4 to the n is centered at negative 4. So remember that it's x minus a. So the sign matters. So think about it. I know it's hard because if it's a minus sign, so you'll think the center is at minus 2. But remember, whenever there's a minus sign, that means it's a positive, the center is positive. And whenever you see a plus, it's the opposite. So there are 3 convergence possibilities for a power series. So let's say we have a series of x minus a to the n. Then there are only 3 possibilities. So the first one is it converges when x is equal to a. It converges for every real number x. And lastly, if there's a positive number r such that it converges when the absolute value of x minus a. So I flipped the signs. Actually, no, I didn't. Wait. Yeah, it converges when x minus a is less than r, and diverges when x minus a is greater than r. And that number r is called the radius of convergence. So I know it's in the bottom, but there's also something called interval convergence, where it's just a minus r comma a plus r. So if the center is a, then the power series converges inside a distance r from it, right? So the open interval is going to be a minus r and a plus r. I know it sounds confusing, but this is really simple. It'll make sense whenever we actually do some examples. So how do you find the radius and interval of convergence? So here's kind of a breakdown. So first you want to identify the general term, which we've been doing for everything, even before power series. Then we use the ratio or root test to find where the series converges. Then we solve the inequality. We usually get something like x, the absolute value of x minus a is less than r. That gives you the radius and the open interval. And then you plug each endpoint in separately to the series to test if they're included or not. Sorry, that was step 5, I went ahead. So you plug it in, then you test the endpoint, and then I guess there's also a step 6, I guess if you want to call it. I didn't think about it, but I guess you just write the answer, or you write the final interval. So now, let's move on to our first example. So we have example 1. Find the radius and interval of convergence of the series x to the n. So let's write the series out. So it's the start at 0 and you keep going, right? So let's plug in a few numbers. So n equals 0, n equals 1, and let's do n equals 2. Let's just do 3. So you have x to the 0, and anything to the 0th power is just 1. Then you're going to have x to the first, which is just x. You have x to the second, which is just x squared. So you should be seeing a pattern. It's like 1 plus x squared. You just keep adding x's, right? So you should know from, well, I don't know if last unit, but you should know from the series or this chapter that this is a geometric series, right? So I'm going to erase this really quick. Sorry, I erased it before I told you I was going to erase it. But this is a geometric series with a, or the first term, being equal to 1, and your r value being x, or the common ratio. being x. So now let's use a geometric series rule. So we know a geometric series converges when the absolute value of r is less than 1. So since our r is equal to x, we're going to need the absolute value of x to be less than 1. So as you can see, this means that the radius is 1. And how do I know? Because if you learn in algebra that whenever you have like an inequality with an absolute value, to get rid of the inequality, you like take the negative sign, right? So it's going to look like -1 is less than x is less than 1. I don't know how to explain it properly, but like whenever, maybe you already know, but whenever you have an absolute value inequality, if you just like to remove it, you just add like the opposite number. Like for example, let's say it was x is less than 2, then it would be, to remove the absolute value, we put the negative and positive on both sides. So -2 is less than x less than 2. Oops, sorry, it's slanted, and I don't know how to like word it properly, but I hope that makes sense. So we got our inequality. So we know that our radius, since the center is at 0, right, just x to the n, there's no x minus a or anything. We know our center is at 0. So our radius, or the distance from our center to the endpoint, is just 1, right, on both sides. So we know you can write r is equal to 1, and the open interval is -1 to 1. Now, just because you get that, don't box your answer, because let's read the question. It said to find the radius and interval of convergence. We just got the interval, but we never tested the endpoints. If you remember, we still have to test our endpoints. So let's plug in a 1 for x. So I'll do on the side here. So x equals 1. We're going to get 1 to the n. Well, all the numbers you plug into this is just going to keep giving you 1. Is just going to be 1 plus 1 plus 1. These are just going to keep getting a series of plus 1s. So you know that these diverge. So we don't include the x equals 1. Now let's test a -1. And when we have -1, we're going to get now this looks like an alternator, right? So if you remember, what an alternator does, it just flips the sign, right? So this will look something like this, like 1 minus 1 plus 1 minus 1 plus 1. Just keep going on forever, right? The plus is minus. So you know these also don't approach a number, so this also diverges. So let's write diverges. Therefore, the endpoints. So basically, the only reason we're testing the endpoints is to see if they're included. So since both of these endpoints are not included, our final answer is just our interval of convergence is just -1 to 1. Now, honestly, if you don't know, what's it called? If like, let's say you can't, like, I don't know, you forgot how to like plug in or test a series, right? You can always just box this in. Like, you have a slight chance it'll be right, hopefully. I guess you can pray. Because sometimes one of the endpoints could be included, one or both could be included. Sometimes it could only be one, sometimes it could be both, sometimes it could be none. So you have like what? A 33% chance of getting it right. If you don't want to test the endpoint, just box it in. Not a good idea, but depends on if you want to test your waters, I guess. So let's go to example 2. Find the radius and interval of convergence of x to the n over n. So in this one, we're going to be using the ratio test, because there's no, you notice it's not geometric because it's a denominator. It's not a p series. And the ratio test is going to get rid of the x to the n, or it's going to it'll make it cleaner. So, by the way, I'm going to be going through these really fast, so if you're stuck with the series things, you should go check my other videos, because you should have mastered all the series by now, and they should just be you should see a series and you just know, oh, we're doing the ratio test and stuff like that. So you should be really comfortable with the series, by the way. So let's write out our general term. It's going to be x to n over n Then our plus 1 term is just extend plus 1 over n plus 1. Then we form the ratio. Don't really need the absolute value signs because all these are positive, but so this is just going to be now the only reason I didn't write it like in the denominator, like I didn't do x to the n plus 1 over n plus 1, then divide all that by x to the n divided by n, is because you're going to end up flipping the fraction to multiply, right? So I just skipped the division step. So if you're confused on how I got multiplied by n over x to the n, write the whole thing out, then you'll see you'll just multiply by the reciprocal of the denominator, right? And you'll just get times n over x to the n. So it just saves space. So now we simplify, right? So let's go ahead and simplify these two terms, the x to the n's. So we know x to the n plus 1 over x to the n is just equal to x. I've explained this a lot in my other videos, but just really quick, plug in a number. Let's say you plug in n equals 2, right? So on the top you'll have 2 plus 1, so x to the cubed, or x to the third, and then x squared, right? So, and you know, when you divide by an exponent, it's subtraction, so 3 minus 2 is 1, so it'll always leave you with x. That's the way to think about it. And then for the fraction n over n plus 1, we can just leave it like that. Not really nothing needed to simplify. So now let's take the limit, right? See if this equals 0. So we're going to have the limit, the limit as n approaching infinity of, well yeah, keep the absolute value signs by the way. So we're going to have the absolute value of x times n over n plus 1. So we know that this absolute value of x, right, is going to be constant, right? Because look at the limit as n approaches infinity. We don't care about the x value, right? So we only need the limit of the n over n plus 1. So we can just keep this absolute value of x on the side, right? So it's like a, what's it called? This thing, yeah, treat it like a constant. So let's focus on the limit as n approaching infinity of n over n plus 1. Now if you know, this just equals 1, but if you don't, we can just divide everything by n really quick. That's just 1 over 1 plus 1 over n. 1 over infinity is just 0. So 1 over 1 plus 0 is 1. 1 over 1 is just 1. So your limit is just equal to absolute value of x times 1. Or you can just say absolute value of x. So now, for a ratio test, for its conversion needs to be less than 1, right? So, and we know that our radius is equal to 1. So let me round the corner here. So we have the value of x needs to be less than 1. Or you can just write it as this, with r equals 1. So we know our open interval is just -1 to 1, kind of like last example. So I'm going to need space to test the endpoint, so I'm going to erase all of this. So now let's plug in x equals 1. It's going to be it's going to be 1 to the n over n. So you know, one no matter what you plug in for the n for the 1, it's just going to equal 1. So we can just rewrite this as 1 over n, or sorry, I forgot the series notation. And this is a harmonic series, and you should know this diverges. Therefore, x equals 1 is not included. Next we have x equals -1. So it would just be negative 1 to the n over n. So this is an alternating series, right? So you know in alternating series we take the absolute value. So your term, so let's write your term is just equal to, we take the absolute value of this, is just going to, the negative 1 to n, remember it's an alternated absolute value, just makes it 1. So this is just going to be equal to 1 over n. Now the two conditions for the alternating series test if that they're decreasing and the limit approaches 0. As you can see, 1 over n is decreasing, and the limit as n approaches infinity for 1 over n is 0. So this converges, right? So that means we include this negative 1. So your final answer should be negative 1, comma 1. This is what I mean by when you have a 33% chance of guessing, because technically you could just box that in once you know your interval of convergence, but you always have to test the endpoints, right? So in this case, the negative 1 was included because it converges. So whenever something is included, we write it in a bracket, not in a parenthesis. So if you didn't know that, I guess there's that. Now, for the next example, find the radius and interval of convergence of n times x to the n over 3 to the n. So this is a power series with x to the n, 3 to the n, and also another n. So let's write our general term, like you should do it with every series problem. So, oh yeah, also for the test. If you can see, we're going to be using the ratio test, because the ratio test will simplify this. So I won't explain why and everything, because you should be really familiar with this, and I've heard that my videos are a little bit too long, so I'm trying to make them a little shorter. So if you're not understanding why this is a ratio test, you can go watch my video on ratio test. Then we have a sub n plus 1 is going to be equal to so now we got to form the ratio. So ratio is just so I'm not going to divide, I'm just going to multiply it, like reciprocal already. So now let's simplify, right? So let's start with these. Let's start with the x to the n plus 1 and x to the n, because these are always the easiest to simplify. So I'll do in blue, I guess, since I'm already have it. So x to the n plus 1 over x to the n. Remember, just plug in a number, but this is just equal to x. I already showed this last time, so I'm gonna hope you know. Now let's do the 3 powers, so 3 to the n and 3 to the n plus 1. So you're gonna have 3 to the n over 3 to the n plus 1, and this is going to give you 1/3. You can plug in a number, so I'll plug in one really quick. Let's plug in a 2, right? So that's 3 squared over 3 cubed. I guess 2 plus 1 is 3, so 3 squared is 9. 3 cubed is 27. 9 over 27 can be simplified to 1/3. So that's a way of knowing that. And then lastly, we have the n parts. Whoop, I need to add a color. Let's do my favorite color, purple. So we can just leave the n plus 1 and n as the same, because we always take the limit of the n's, right? So I guess it doesn't really matter. It's not really complicated, right? So we'll keep the n plus 1 and everything same, right? So now our simplified expression becomes, right, equals here. So n plus 1 over n, we'll just group these together, times, and we still have the absolute value of x over 3. Always keep the absolute value signs for the x's, by the way. I don't know if I said that last example, but just always have the absolute value there. So now we take the limit. So I'll do on the side here. So the limit as n approaching infinity of n plus 1 over n times absolute value of x over 3. And we can just, absolute value of x over 3, remember, we plug in an n for infinity, so we can just keep this as a constant. So don't worry about the absolute value of x over 3. We'll just worry about that one later. We'll multiply. So let's find the limit as n approaching infinity of n plus 1 over n. If you know, this is just going to approach 1. Because remember, same powers. So you divide by coefficients. Both of them have a 1 in front of it. So it's going to equal 1. If not, I did last example, I think, or the example before, I'm not remembering, but you just divide both sides by n, and you'll also get 1 on your answer. So our final answer is going to be, we have our limits equal to, so 1 times the absolute value of x over 3. So that's just going to stay the absolute value of x over 3. Now, we need the ratio test, right? So we need absolute value of x over 3 less than 1. So multiply both sides by 3. We get, so value x is less than 3, or you can rewrite it as negative 3 is less than x larger than 3 if you don't like the absolute value sign. So you know our radius of convergence, or the radius interval, is just 3. So your interval is going to be negative 3 to 3, or the open interval, sorry, not the. Now we gotta check our endpoints. So I'm going to delete just this small parts right here. So let's plug in x equals 3. So we're going to get, whoops, of n times 3 to the n over 3n. Well, luckily the 3n's cancel, so it's just going to be equal to of n, and this diverges. This should be really easy to tell. Just plug in numbers for n. 1, 2, 3. This is just going to be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. Dot, 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 dot. These terms don't approach a number or go to 0, so the series diverges. Next, let's plug in the next endpoint. X equals negative 3. So we'll have from n equals 1 to infinity. So this will be n times negative 3 to the n over 3 to the n. So we can use this, we can say that we can rewrite the negative 3 to the n, basically the same thing as negative 1 to the n times 3 to the n. Remember, because this negative 1 time, this is just an alternator, right? So negative 3 to the n is just an alternator. So we can just factor it out. This, all it does is just changes the sign, plus 3 minus 3 plus 3 minus 3. So in this case, we'll have, well, this will be equal to n times negative 1 to the n, 3 to the n. These can get really messy, over 3 to the n. As you can see, the 3 to the n's cancel. So this is just equal to, running out of room, n times negative 1 to the n. So if you want to check whether these go to 0, if they diverge, just plug in infinity, right? Negative 1 to infinity, all it's just going to do is it's just going to be, well, as you plug in more numbers to negative 1, you know this is just an alternate, right? It's going to be plus 1, minus 1, plus 1, minus 1. And it's going to be infinity times a series of like plus 1, minus 1. So you know these are never going to go to 0. Therefore, this diverges by the divergence test. So your final answer is just this. From negative 3 to 3, and both these are not included. So I guess this is just like a guessing game. Or, well, not really a guessing game, but let's say you don't want to like actually check the endpoints, then it's really just a guessing game. Next one. Find the radius and interval of convergence for x minus 2 to the nth power over n times 4 to the n. So this is a power series, but the center is not at 0. The center is going to be 2. So we're still going to use the ratio, the ratio test to get rid of the ends. So let's find the term and the term plus 1, I guess. I don't know what you call that. So you get that. Now we just form the ratio. Actually, I'm not gonna do a bottom here. I need to learn how to like write stuff being organized. So that's something I'm terrible at. So that's the ratio. That's just okay. Now we gotta simplify this. So let's simplify these first, x minus 2 to the n. Oh wait, that should say plus 1. Whoops. Oh my god, I wrote all this wrong. Sorry. Good thing I caught my own mistake, or I would just go on the example just doing all this. So I should say x minus 2 to the n plus 1 over n plus 1 times 4 n plus 1. Whoops, hopefully you can still see it properly. It's easy to read. So let's simplify the x minus 2. Well, x minus 2 to the n plus 1 and x minus 2 to the n. Now don't get scared because it says the x minus 2. Just think about it as the same number, right? Here, I'll explain what I mean. So just think about there's a 4, right? Like the x minus 2, the term inside doesn't matter, right? N plus 1 over n is just going to be equal to, like, let's say there was not an x minus 2 and there was just a 4, right? So 4, or sorry, maybe 4 is too big. Let's just say there was a 2. So it was 2 to the n plus 1 over 2 to the n. So let's plug in like a 3, or sorry, a 2 as well. So 2 times 2 plus 1 is 3. So 2 cubed over 2 squared, because 2, n equals 2. So 2 cubed is what, 8? No. Yeah, and 2 squared is 4. So 8 divided by 4 is 2, right? It's just that term. So it's just going to be equal to x minus 2. So if the x minus 2 to the n plus 1, like, I guess messes with your head, just replace the x minus 2 with a, I don't know, a number, like a constant. Because we're not dividing the x minus 2's, right? We're only dividing, well, we are, but we're just dividing the exponents, actually. And then, let's simplify. Let's see, what else can we... Okay, we can just simplify these two then. The 4 and the 4n plus 1. So, 4n over 4n plus 1. I think we did this 100 times, and I showed it like a couple examples ago, which is equal to 1/4. And then we can just leave the n and the n plus 1. We don't really need to simplify this. So most of the simplifications in this problems are going to be like the exact same, so you'll get used to it. You'll just memorize what they equal to. You want, or better enough, you'll probably learn, like, if you forget, you can just plug in the numbers and just check them yourself. So the ratio now becomes, doing the bottom left here, so we left the n over n plus 1 untouched, so n over n plus 1 times the absolute value of x minus 2 divided by 1/4. Oh, sorry, just divided by 4, because there's already, okay. So now we need to take the limit. Remember, this is just a constant right here, the x minus 2 over 4. We only worry about the ends. That makes sense. So if you already know, I think we took this limit like, what, 2 times already? This is just approaches 1. So the limit is going to be equal to, so L is equal to x minus 2 over 4. Now let's apply the ratio test. So less than 1. Multiply both sides by 4. So we'll get if you want to get rid of the absolute value signs, you can do that. So just by adding the negative. Then I like to add 2 on both sides. So you'll get negative 4 plus 2 is just negative 2. It's less than x. And 4 plus 2 is 6. So as you can see, your center is at 0, or sorry, not 0. Your center is at 2. Remember from the start of the problem? It's x minus 2. Your center is at 2, right? So from 2 to 6, you need 4 spaces. From 2 to negative 2, you also need 4 spaces. Well, from negative 2 to 2, you need 4 spaces. So you know your radius of convergence is 4. So your open interval is just that. Or you can just write negative 2 to 6. Now we gotta check the endpoints. So let's plug in x equals 6. I just like to start with the highest number for some reason. If you want to start with negative 2, you can. You can go ahead and try to do it without me. So let's plug in a 6. So that'll be 6 minus 2 power of n over n times 4n. If you can see, this just gives you 6 minus 2, this is just 4n over n to the 4n. These cancel out, leaving you with 1 over n. This diverges. So harmonic series again. Now let's plug in the negative 2. So for x equals negative 2, we get, well, negative 2 minus 2 is just do that math in our head, just negative 4 times n over n to the 4n. If you remember, we can rewrite the negative 4n as negative 1 times n times 4 to the power of n. Because remember, this is just an alternator, so the negative 4 n, all it's just going to do is just say plus minus 4 in 4s, the power of 4s. So you can just factor out a negative 1. So this is equal to, well, yeah, actually, I was thinking of skipping a few steps and writing it, but it's probably helpful. So it's just equal to negative 1 to the n times 4n over n times 4n. 4n cancels, so you're left with, well, keep forgetting to write the series notation. Well, this is an alternating harmonic series, right? Take the absolute value, right? You'll get, this is going to equal to 1 over n. You know 1 over n, it gets smaller, so it is less than the next term. It is decreasing, and you know the limit of 1 over n is just 0. 1 over n is just 0, so you notice converges. So we do include x equals negative 2, so I'll just write converges on the bottom. Now I know it went fast, but this is like how I expect you guys to like be familiar with series like this. So I guess I'll write it at the top right where there's space. So the interval, the radius of convergence is just 4. And then our interval of convergence is just negative 2 to 6. Remember, we write brackets when something is included. So that's your interval of convergence, and that's the radius of convergence. Holy stutter. Recap lastly. For power series, all you gotta do is just identify the center, use the ratio or root test to get the interval. Find the radius from the inequality. Remember, to get rid of the absolute value, just add the negative side to it, if that makes sense, hopefully. And then you just test each endpoint separately. And I don't know if I mentioned, but to test the endpoints, make sure you plug them back into the original series, not the one you already simplified, the original series. So, hope this helped you. Have a great day.